Right, this is section 16b and 16c, increasing and decreasing functions, the flipped lesson. First of all, we want to look at what does it mean for a function to be increasing or decreasing. And really what it comes down to is what are the tangent lines doing? Okay. As we look at this function here, y equals x squared, along this side, this left-hand side of the origin, you'll notice our tangent lines are all going downhill, which of course means that our derivative, f prime, is negative. Okay. Over on this side, you'll notice our tangent lines are going uphill, which means that our derivative is positive. And the reason why we know these are negative or positive is because of the slope of the tangent lines. Okay. Now, when we're looking at these, we can look at the intervals where the function is increasing or decreasing. For example, here you know from the fact that this is a parent function that our minimum point is here at the origin 0, 0. So what we would say is that our function is decreasing from negative infinity up to 0. Now we will use set it equal to 0, and we'll talk about why later on, but we would say it's decreasing over that interval, and then of course on this side where the derivative is positive, our function is increasing. And that would be the interval from 0 to positive infinity. Okay. Now if we go down here, you'll notice we have a cubic function, and they've labeled for us the max point and the min point. So we have here an interval where our tangent lines are going up, so it's increasing. And also this interval over on the other side, it's going to be increasing. Alright, so we would say it's increasing over the interval from negative infinity to negative 1, and the interval from 2 to positive infinity. Okay. Then in here in this region, we see that the tangents would be going downhill, so we would say that it's decreasing over the interval from negative 1 to positive 2. Okay. Now, how does that relate to the derivative? Again, because our tangents are either going downhill when it's decreasing or going uphill when it's increasing, our tangent and the slope of our tangent would be negative. Once again, f prime of x from negative infinity up to 0 is going to be negative, and f prime of x from 0 to positive infinity would be positive. Okay. Likewise in the cubic function over here, f prime would be positive here, it would be negative in this region here, and then it would return back to positive over here. Now some functions increase all the time or decrease all the time. We would call these monotone, increasing or decreasing. Monotone, someone has a monotone voice, it's very the same all the time. So likewise with our functions here, if it is increasing all the way from negative infinity to positive infinity, we would say it's monotone increasing. like this function y equals 2 to the x. Now what we can say, there's a term here, and this isn't one that the IB requires you to distinguish, but you'll notice before I included 0, I'll go back here, I included 0 in the intervals, okay, in both intervals. And you might think, well, how can it be decreasing and increasing at 0? Well, if you think about it, you remember that the derivative would actually equal 0 at that min point. Also, down here, we included -1 and 2 in all of the intervals. Well, that's when we just say it's increasing or decreasing. If we're talking about it strictly increasing, that's when we would have said it approaches -1 but it's not equal to, or approaches 0 but it's not equal to. It's a fine technicality that, again, the IB doesn't require you to distinguish between. Okay, so as we have a function going like this, we would say that 2 to the x is monotone increasing. We would say 3 to the -x is an example of one that is monotone decreasing. Now, let's take a quick look at sign diagrams. Here's a function, f of x equals x cubed minus 3x plus 4. And they've graphed it for us, and they identified that the max is going to occur here at -1, and the min is going to occur at 1. A sign diagram is a number line like you see over here on the right. And the way it works is when we identify these points, -1 and +1, we put those on our sign diagram. And we recognize that our function has now been divided into 3 regions. And what we can do at this point is we're going to test the derivative for what the sign is going to equal. So the first thing I need to do is take f prime of x, which in this case is 3x squared minus 3. And what I'm going to do is I'm going to plug in these values, a value that's in the region. All right, so for example, I'm going to test -2, I'm going to test 0, and I'm going to test +2. Now, when I do f prime of -2, you can do the math here, but -2 squared is a +4, 3 times 4 is 12, minus 3 would be a +9. The value really doesn't matter. Really all we care about here is the fact that it's positive. So in our sign diagram, we know our derivative is positive here, which means our function is increasing. In the middle here, if we do f prime of 0, 0 squared is 0, times 3 is 0, minus 3 is -3. So here we see that the derivative for not only 0, but every point in between -1 and 1 is going to be negative, so we know it's decreasing. And then we check the other end at f prime of 2. F prime of 2, we have 2 squared is 4, times 3 is 12, minus 3 is again a +9. So we are positive, which means we are increasing. Alright, so real quickly, that's a really easy way to see the intervals where it's increasing or decreasing. So we would say that f of x is increasing on the intervals from -infinity to 1, and then also from 1 to +infinity. And then we would say that it is decreasing on the interval from -1 to 1. But one question you might be asking is, well, where did this -1 and 1 come from? Okay. Those are what are known as critical values. Your book will call these stationary points. Now, these are values where our derivative, our tangent line, is horizontal. We've actually found these before. We just haven't applied them to graphs quite as much and looked at increasing or decreasing. So as you look here, if we look at our f prime of x, 3x squared minus 3, and we were to factor that and set it equal to 0, you can see that the values of x that would make it equal to 0 are -1 and +1. Okay, we already saw the sign diagram, but x equals -1 and +1 are the critical values. Critical values. Now, critical values are just one of the things that we will use in our sign diagrams. Another thing you need to consider is continuity, which we'll deal with in our next lesson. So we'll be looking at the domain, we'll look at asymptotes and whatnot. But for right now, as we're introducing this concept, we'll be looking at just polynomial functions that have a domain of all real numbers. So, let's take a look at a quick example here. Okay. And ask ourselves, are critical values always max or min points? And the answer is actually no. There can also be plateau points. Now, taking a step back, how do we know that these are max or min points at -1 and +1, and they're not just plateau points, which whatever those are, we haven't talked about that yet. The key is that we are changing from increasing to decreasing. If I was increasing and I changed to decreasing, that's going to give me a max point. If I change from decreasing to increasing, that's going to give me a min point. Okay? If I had an interval, if I had a case like this where it's y equals x cubed, my derivative is 3x squared, the only critical value there would be at 0. So if I were to try -1, -1 squared is a +1 times 3 is +3. So I get a positive, which means I'm increasing on the left hand to the left of 0. Okay, we know actually there's a 0.00 there. Also to the right, if I tried +1, 1 squared is 1 times 3 is +3. So I get a positive derivative, and I'm increasing here. So what happens is we do have that horizontal tangent right at this point, but that's because our graph has leveled out. Notice we're increasing. It levels out for a moment, and then it continues to increase. All right, that's what's known as a plateau point. Okay, we will run into those, but that's where the sign diagram is particularly helpful. Okay, now I'm going to stop for a moment, and we're going to look at one example here at the end of actually graphing an entire function just based off of looking at increasing and decreasing intervals, as well as a little throwback to our algebra and finding zeros. So we'll look at that on the next video.